Okay, welcome to the Cameron Park Rotary Community Observatory. We're having a few difficulties getting on the air here, but I think we're starting now. This is the Great Hercules Cluster M13, and we're just getting set up, and hopefully we'll have a whole list of things here in just a minute. Cameron Park Rotary Community Observatory. Yeah, we are having some audio issues. Okay, but it does sound pretty bad too. Let me see if I can fix that real quick here. We'll try just without this graphic over there and see if this changes anything. I'm gonna have to listen here for a second. Sorry, folks, we're having some audio problems. We'll try just well, you might have to bear with me on that. I don't know if I can get this audio to sound any better. We'll try one more thing here. Testing 1, 2, 3, 4, 5. Testing. Test 1, 2, 3, 4, 5. Okay, well, we'll have to bear with it, I guess. I'm sorry about the audio, but we'll go ahead and go through some things here. We're looking at the Great Hercules Cluster while we're getting set up. I'm going to try resetting one more thing here, see if that helps. Test 1, 2, 3. Should have no audio right now. Yep. And if I do this, does this bring in the audio? But how does it sound? Test 1, 2, 3. Testing 1, 2, 3. Anybody out there on MSN hear my audio? Does it sound bad to you out there? It sounds real crackly to me. If anybody can open up a chat window and let us know if they're hearing the audio. Otherwise, we'll just go ahead and get started. And I'll show you the Great Hercules Cluster here for a minute and get the rest of our list together. Well, what's first on the June list out there? We had some difficulties getting on the air tonight. Sorry, folks. Okay. Let's go ahead and head over there. What did you say, 3628? Okay, we'll go to NGC 3628. So, Okay, we're looking for NGC 3628. Looking on that here. Might have to turn up the integration a little bit. It might be that they're in the middle, a little fuzzy dot. We've got Olin in the telescope room helping me out tonight. And Robin here on the chat window, so if you have any questions, feel free. Right now we're just trying to get our feet on the ground and get this thing rolling. NGC. Okay, so, do I sound audio? Yes, I do. As much as it is. NGC 3628 is a 9.5 magnitude type SBP peculiar galaxy in the constellation of Leo. It's seen only 3 degrees from edge on. This galaxy displays a prominent warped dust lane, but I'm not seeing that, Olin. Can you see it out there? Uh-oh. 3628 in Leo. And you're looking toward Ursa Major with the scope? Well, where's the iPad? Let's see. I may have typed in the wrong coordinates on that one. One little typo on an RA or deck, and it points you in the wrong place. Okay. Connecting. So we don't know where we are. So let's just call it setting up telescopes for right now. Okay. So connect. You're right. We're just off of Doobie, huh? Well, let me do it this way. We'll go. Here's our gene list. 3628. Scope moving. I need to mark that one down as edit that one in the touch panel on. Nothing like starting off on the wrong foot. Now, is that pointing toward Leo now?
Yes, indeed.
Okay. So, let this thing refresh here. Bring this up a minute. Settings. I'm going to leave that up for a minute. So, are you seeing it yet? Okay. It's pretty small. Let's see here. Yeah, we should see it with a dark dust lane in there. Turn the integration up a little bit farther. Okay. We'll let this thing work. In the meantime, here's what our sky looks like tonight. You can see fairly clear sky, a couple of high clouds, and if you look, we've got Looks like our tour is almost straight up at the zenith there. It's from our all-sky camera. Let's see. That got darker. You sure you turned it clockwise? Oh, okay. Okay. Well, you know what? Let's go to. Yeah, let me take you over to Regulus for a minute. Scope moving. We'll get centered up on Regulus here, and that'll tell the tale. Well, now we got more background. Maybe we just didn't wait long enough for it to integrate. So it looks like it went clear past Regulus, huh? Yeah, turn the integration down to minimum since we're on Regulus. You guys are getting all the technical stuff here on the webcast. In the wintertime, we have plenty of dark to get set up before we start doing these things. It's so dark so late these days. Okay, so where is Regulus? We didn't even see it. How, you set it up in the Telrad? Okay. Because I'm not. There it is. Okay, send that up. Yeah, we were off a good 3/4 of a degree. No wonder we didn't find the galaxies. Did you sync on M13 earlier? But that was a meridian flip?
Yes.
Okay. A little bit to the right. Okay, so that's Regulus. Okay. 3628. I can do that. Okay, we'll go back. 3628. Okay. Now, I recognize the star field. Oh, I see it. Yeah, turn that thing up half a turn. That's it right in the middle, right? Using my imagination, I see it there. There it is. Okay. Okay, now we're off and rolling. Okay. This is NGC 3628. It's a 9.5 magnitude type SBP peculiar galaxy in the constellation Leo. It's only 3 degrees from edge on, so this galaxy displays a prominent warp dust lane right there in the middle. The nuclear core appears mottled and indistinct. The object has a diameter of 78,000 light years and is an estimated mass of 135 billion suns. How does that compare to the Milky Way, Robin?
We have 152,000 light years across, 12,000 light years deep.
Yeah.
And we've got about.
How many billion suns?
I've lost the count.
Okay. Yeah. Well, we'd have to ask Forrest that one. So, but there it is. Looking okay. Okay, so next is NGC 4490. See if you can pull that up on the touch panel out there. Yeah, you can just minimize that. Okay. After the scope integrates out a little bit, I see something changing. There we go. Okay. This is a 9.8 magnitude type SB DP. That'd be a spiral barred something peculiar. I'd have to look up. I'm sorry, I don't know the abbreviation on that one. It's a peculiar barred spiral galaxy. Okay, that's just what that means. I guess the BD is barred. This galaxy is in the constellation Canis Phamactesi, and it's also known as the Cocoon Galaxy. It forms an interacting pair with a nearby NGC 4485 with a diameter of only 35,500 light years. This object is seen tilted 65 degrees from face on and sports a faint tail directed at the fainter companion galaxy. Haley, did you have a question?
You mentioned, is that similar to the whirlpool?
Is it similar to the whirlpool?
Like as far as the interaction goes?
Yeah, I guess so. The two galaxies have interacted with each other. It looks like it's pulling an arm out type thing. Things are it's exactly the same except different. How's that? Yeah, it's very, very similar. But I don't think the whirlpool is not a barred spiral, so I guess that's the difference. Sure, we could go to M51 just as a comparison. You want me to take that, or you want to go get it out of I think it was in the April list? So go ahead and head over to M51. I'll get that prepared in here. But that's looking pretty nice. Yeah, it does have a bright nucleus. M51, one of my favorites. It's also in Canis Phamactesi. Did I spell that right? I hope so. Okay. We still have a little bit of a remnant of the other one fading out there. Time exposures sometimes give us double exposures. Very nice structure on the whirlpool tonight. Benefits of having a new moon. It's just finally starting to get a little bit dark here. It's 10:04 Pacific time. There we go. Nice.
That's about 15 to 23 million light years away. It's a typical barred spiral galaxy, similar to ours. 51A and 51B. 51B is the smaller one at the bottom of the screen, and scientists believe that it passed underneath 51A about 600 million years ago, and the gravity, one theory is it pulled toward the arm with it of M51A. There's also talk that it may come back.
Yeah, I've heard that it was in front at one point, and now it's behind. And it came from behind, came around the front, and circled back behind, and
Right.
so it's gone through. Yes, Haley.
No, it pulled the arm of the larger galaxy. With how massive the larger galaxy is.
Well, so Haley's asking the two galaxies interacting. The larger one seems to be more affected than the smaller one, from what you're saying. I would guess that would be because the larger one has more diffuse area farther out, and the smaller one is more compact. It'd be harder to see the perturbations of the littler galaxy, I guess, because it's more of an elliptical galaxy. So that would be my guess. But those arms, even though they look connected, the determination is that that arm that looks like it's touching the smaller galaxy is actually in front of it, and the galaxy is receded behind it. So it just kind of, it's like in a wake, rather than, it's not actually gravitationally down to those stars. It just caused it to stretch out a little bit more.
Just destroy.
Yep. Okay. Next on our list will be M88. You want to take us there, Roland? My camera in the chamber is not working right at the moment. I can't show you guys working the telescopes in between, so you're just going to see blurry stars. I'm trying to get that up in between here. Yes, 88, correct. Do we have a fancy name for M88? I'm just going to say it's a Seaford galaxy. Okay, scope's moved over there, and we're waiting for it to refresh here. Well, if the audio doesn't work, we'll at least just have the video and the captions, and we'll just run that during the fair or something. So we'll just turn down the audio. I hope you guys are hearing me and it's not too obnoxious, but there's a bad crackling sound for some reason on my microphone. And rather than abort tonight, let's just blast through here, because you guys can read what's on the screen if nothing else. So M88 is another 9.5 magnitude spiral galaxy in the constellation Virgo. It's tilted about 30 degrees from edge on. It's classified as a Seaford galaxy. Relatively bright nucleus that is known to vary in intensity over time. Coupled with a spectrum that suggests it is powered by a very active supermassive black hole. So there's the kids are always asking to see a black hole. Just say, yeah, that bright spot in the middle. Wait a minute, why is it bright? So
surrounded by stars.
Yes, it is. So there's M88, pretty little galaxy. There's a lot of galaxies there in Virgo, in that same area. Let's go over to M90 and then M91. We'll check those out. Those are all in Virgo. Okay, scope moved. Didn't move very far, did it? I'm sorry? Stevens Quintet. It is. It was in our February list one. Stevens Quintet. I think it's. I want to say it's in Leo, but I'd have to double check. Anybody commenting out there? Oh, we got some things. That's not M88 anymore. Let's get this fixed here. This is M90 now.
Yes.
Let's fix that title then. Okay, so this is M90, a galaxy in Virgo. It's a 9.5 magnitude spiral galaxy in the constellation of Virgo, with a very bright star-like nucleus and an arc of stars that extends westward from the nucleus. Take a look and try to detect hints of the central bar and an S-shaped outer arms. Yeah, okay, I can see. Whoops, a little darker. You gonna try to turn that back up again, or?
Yes, I did.
Okay. We'll wait for it to do another sample. Yeah, I was just starting to see the spirals, and then they kind of faded out, but I can still see those. So M91. So yeah, do you see those? Yeah, I guess kind of an S shape. It's kind of there's a double dust lane there. Let's go ahead and go to M91. And scope moved. And we'll wait for the refresh here. Nice thing about dark skies, we can do longer integrations. A lot of times we have the moon out, and we can only get about 20 seconds without washing out the sky. So we're doing what, probably 30, 40-second integrations tonight. Takes a little bit longer to move between objects. There we go. So there's M91. And M91 is a 10th magnitude galaxy. It's a little bit dimmer, but I see more of a bar there going. So you can turn that up just a little bit more. I know it's going to wash out the background a little bit, but I'd like to see if I can see more of the spiral. M91 is a 10th magnitude large spiral galaxy in the constellation Virgo. It occupies a contentious position in the Messier list. The position of the object listed by Charles Messier as a bright nebula in his original observations does not correspond to any object through the eyepiece. After many years of astro sleuthing, the current is that Messier was actually observing nearby NGC 4548 on a very dark night. This object may display a central bar and hints of a hazy halo of stellar arms.
NGC bar.
Did a satellite go through there?
Yeah.
Nice. So, this is NGC 3628. Oh, okay, yeah, the iPad wasn't locked to scope, that's why. So this is M91. I just want to see NGC. Forrest is telling us 4548 is nearby. Let's see if that's NGC 4548. Is it the same thing? Tell me if the scope moves at all. 1, 2, 3, go.
Nope.
Okay. I'm trying to figure out what he says in the script about the Messier was actually observing nearby NGC 4548. So, oh, I get it. They've adjusted M91 to be NGC 4548, I bet. Google info on this. Yes, okay, same thing. NGC 4548 and Messier 91 are currently the same thing, but if you looked at his coordinates, what they were saying was they were a bit off, I guess. I don't care. It's kind of cool. The little spiral there. Double image there a little bit. 4536 is our next one. You want to take us there? A lot of galaxies tonight. July is a Virgo galaxy night. Or June, I guess. We're not in July yet. Keep me honest, Robin.
I'm doing fine.
Yes.
Do all galaxies have galactic halos?
Do all galaxies have black holes in the center? Is that what you said?
Galactic halos.
Oh, galactic halos. That's a good question. What's the definition of a galactic halo? So I guess
Maybe any galaxy with a structure.
any galaxy is Jason out there? Oh, any galaxy. Thanks, Jason.
Can you see?
I can't see out there because it's the computer screen's in here. All I see is black and the red rope lights.
Can you see the galactic halo on any of the Melanchthon galaxies?
I don't think so. That's I don't know because I haven't studied that. Okay, so where are we at now? I lost track. NGC 4536. I gotta get the title changed. 4536. So this is also in Virgo, isn't it? Yeah. Okay. Someday I'll have all these typed in here in advance. You got another satellite through there. Okay, NGC 4536 is an 11th magnitude type SAB barred spiral galaxy in the constellation Virgo. At low magnification, the companion spiral NGC 4527 may also be glimpsed. You see another galaxy in there?
You see a galaxy near the bottom.
Oh yeah. Yeah, good. So right at the bottom there, we'll take this out. Sure. Yep, there's another galaxy there. Move that up a little bit. So that's NGC 4527 down at the bottom. So there's also a quasar right near here, which I can probably take you to. You know, let's try to do that. Let's go. Let me see if I can find that here. It's 3C 273. And I'm going to move the scope. On scope moving. Didn't move very far, did it? Yes. Did it move?
Yes, it did.
We're going to quasar here. I guess it's still kind of an M91, so it's hard to see. Let's let this calm down a little bit. Yeah. Right in the middle is supposed to be the brightest quasar in the sky?
Can you have a quasar without a galaxy?
What's that?
Can you have a quasar without a galaxy?
I don't know. This is a quasar in Virgo. It's located 3.5 degrees northeast of 15 Virginius. It's the brightest example of a quasar. Quasars are thought to be the most luminous objects in the universe. They are strong radio sources and show enormous red shifts in their spectra. This implies that they lie at distances far beyond the most remote galaxies and therefore are most distant and some of the oldest objects astronomers have detected. However, there may be other causes for their extreme red shifts and astronomers do not yet understand. So, are quasars outside of galaxies and just rogue?
I thought they were galactic centers.
Galactic what?
I thought they were usually in galactic cores.
In the cores?
Because I thought that's what made them so bright was debris falling into them like black holes.
Okay. I'm not sure about that. Oh, well, that title was bad. I shouldn't have had that up. So. All right, so next on our list, is what, M104? So we're going to go M104. What are you trying to do? I'll get rid of a little bit of that red. Is that cap on the back end of the scope? Yeah, the one over the eyepiece cover. We could be getting some red rope light in there. You know the one I'm talking about? Nice.
I've been waiting a year to see this.
Let's see here. M104. You've been waiting a year to see it?
I've been waiting a year to see it.
Nice. Well, there it is.
Every time I try to see it, it's below the wall.
Is that cover on the tag? It wasn't on?
It was on.
That's,
I put it on.
so that's where the red was coming from.
Thank you. Yeah, you're also pointing that way.
Well, it definitely was different. So, 104. Yeah, we have a little light leak in the back end of our telescope because our if it's not covered up right. Olin, go ahead and check the white balance again. Let's neutral that out. Go back there. Bring that red up a little bit. Yeah, about there. Okay, good. All right, so there we go. So M104 is an 8th magnitude spiral galaxy in the constellation Virgo. It's commonly known as a sombrero galaxy. Is it upside down?
It's edge on.
This is always a sure hit with the visitors. M104 is easily seen in scopes as small as 4" and tolerates moderate magnification well. The very bright core seems to illuminate the spiral arm structure and is bisected by a prominent dust lane. In his book, The Messier Object, Stephen O'Meara claimed that he had seen a high magnification with the core glowed with a distinct yellow light. It does look kind of yellowish compared to some of the others. All right. Ready for NGC 4565 is next. Another galaxy. It's a nice night of galaxies. So right next door to Virgo, we have Coma Berenices, right? So that's where we're headed next. So the scope's moved. We're waiting for the integration changes. There we go. NGC 4565, the Needle Galaxy in Coma Berenices. So this is also known as Caldwell 38, or like I said, the Needle Galaxy. It's a large type SV spiral galaxy found in the constellation Coma Berenices, which is Bernice's hair. My mother-in-law's name is Bernice. A relatively bright 9.6 magnitude, this is truly an outstanding example of a spiral galaxy seen edge on. A prominent dark lane of dust bisects the narrow galactic disk and the bright central core. This galaxy is about 150,000 light years in diameter and has a total mass of more than 200 billion suns. On a very dark night, try to visually detect the dark lane in the 17-inch scope over there. Is that what you're doing over there on the 17-inch, Jason? I can't hear you.
An amateur working over there.
You got an amateur working, okay. Well, we're all amateurs, as proven by this broadcast. But we just love to have fun. So yeah, this is really a nice example of a galaxy, and I see another one up in the upper right too, just going off the screen. What is that? Yeah. What are you looking for?
Looking for something to give me more backfocus.
Oh,
It's
you want to extender?
It's got it right here.
Okay. All right. Next will be.
You asked earlier about how many suns are in the Milky Way galaxy.
Yes.
Well, the Milky Way galaxy, they now say, is about 150,000 light years across, and they're saying also that NGC 4565 is about 150,000 light years across, and science says there's about 200 billion suns in 4565. So the correlation would be that there might be about 200 billion suns in our Milky Way galaxy, approximately the same distance across.
Okay. Yeah, that's a nice galaxy. Stephan's quintet is in Pegasus. That's why we don't see it tonight. You asked about Stephan's quintet. It's in Pegasus. Okay, so let's see. So this is NGC 4565. Ready to go to 4656? Let's go ahead and go there next. It should be 4656. Oh. Yeah, this is getting darker and darker out there. Yep. Not bad for a standard def camera. We need to. We'll get that higher definition someday. Okay, so this is we're at 4656.
Not yet.
Yeah. 4656, and this is in this is back up in Canis Manichesi, up toward the Big Dipper.
Yes. The tail.
Yeah.
know what it is.
It's a galaxy. So NGC 4656 is a 10th magnitude type SBM large spiral galaxy in Canis Venatici, popularly known as the hockey stick galaxy.
I'll buy that.
Hockey stick galaxy? Yeah, I see that. Oh, my nephews would love that one. So Jace and Kyle and all the Currentons down there in Fairfield that came up with the Cub Scouts one time. They're big time into hockey. They play on a team. So shout out to my nephews with the hockey stick galaxy. The key features that are angled, they're the angle tilt of the disk and the apparent offset of the core. Observing a low magnification look in the same field for NGC 4631, a more distant galaxy seen edge on. Where's that one? Don't see it, huh? Okay. Pull this down out of here, see if we see it down there. Nope. Maybe we need a wider field of view to be able to see that. But yeah, the core does look kind of offset. But then what's out there that we can't see on the upper right, huh? Next stop is M3.
It's not a galaxy.
We're finally getting out of the galaxies. Yep. Get into the realm of the globulars. M3. I type fast enough I can get it up there before it shows up. Yes.
Chandler, how what are those lines that spread out?
Those lines that are spreading out, just the way the galaxy is distorted, I think. We're about to lose that because we've already gone on to the next one. But what are those lines that are spread out? Tanner, I'm not quite sure what you're asking there, but if they're spread out, I'm guessing it's the dust lanes of the galaxy, maybe. So this is a nice globular cluster. It's in Canis Venatici also. It's an impressive 6 magnitude globular cluster. It spans 180 to 200 light years in diameter. This outstanding globular contains nearly 500,000 stars. Globular clusters are home to some of the oldest stars in the universe. Unlike most globulars, though, M3 contains a large population of variable stars. At low magnification, look for a hint of color in both the inner core and the outer perimeter. I see a hint of color, but it looks like color artifacts. I shouldn't see that green. We can probably turn the integration down a little bit because we're overexposing the core. Now that we're off the galaxy. No, turn the knob. Give the knob about a quarter turn counterclockwise.
Did he have the white down, the red level?
Yeah, you have the red level down just a little bit.
Yeah.
We just want to see this a little darker just so we're seeing a little more detail in the core of that. Lots of stars. Let's say 3. Okay. Next is we're going to go to Serpens Kaput. Haley, do you know what Serpens Kaput means?
No. What does it mean?
How about you, Robin?
The head of a serpent.
No, kaput isn't dead.
I thought so.
It's the cut off part. Yeah. So there's serpens caudia, I think, is the head, and then serpens kaput is the cut off tail.
Lovely.
So it's actually a constellation. It's like split between. So you'll see. Let's see. Oh, is that below the wall?
No. We just got it was
Oh.
a long journey.
Oh, got it. Okay. So M5 is there. Yeah. Okay.
Okay, it's off the edge.
So if you look at Ophiuchus, he's in the middle, and then there's the two parts of the snake, one on either side. I'm sorry, serpens kaput is the
there a story
head. Serpens. So I guess caudia is the. Oh, there's stories about every constellation. What you got? Wow, this is a double globular. That's awesome.
If you want two, you want three.
Well, if you go up a little bit, it would be three. Yeah. Yeah, maybe take it up just a little bit, and then lock in on it. This is M5 now, huh?
Not the one in Perseus, right?
This globular here? No, this isn't serpens kaput.
Okay.
So,
So the dead part of the snake.
well, yeah. Double stars. Let's see. I'm trying to get a little more. Well, he gets that centered up. And serpents. Yeah, it's interesting. That doesn't tell me whether it's kaput or caudia. If Forrest says it's in kaput, it's in kaput. Okay, let's see. M5 is a globular cluster in serpens kaput, the head of the serpent. It's discovered in 1702 by Gottfried Kirch. It's a 5.6 magnitude conglomeration of stars about 13 billion years old and is approximately 165 light years in diameter. Observers may detect a distinct elliptical elongation among the body of the stars. Of interest is the redshift studies that indicate M5 is currently receding from us at about 30 miles per second in its path around the Milky Way. I always thought it'd be interesting to build a map of all the red and blue shifts with the rotation subtracted out so that it was as if we were standing still and everything else was moving. It would mean that one half of the sky should be blue and one half should be red, right? Because everything, yeah. I don't know, I was thinking about it the other day, now I can't even think that. Too many things on my mind. But it's just thinking about the relative speeds. Everything, a lot of things look like they're going away from us, but if they're going away from us, they could really be coming toward us, but we're going away way faster. So if you stopped, then they would blue shift.
That only works if they're going towards or.
So everything coming toward us would be blue, and everything going past. Right. Okay, from Spain. We on the spinning wheel. Well, we could try.
Un poco.
Give us a shot, and if you have a question, we'll try. Are you hearing our audio okay? I guess so, because they're asking if people can speak Spanish. Okay. So this is M5, right? We're still on M5?
Yes.
Well, my second favorite object is M13. So we'll go to Hercules. Why are these my favorites?
You like pop clusters?
Well, it's when I'm out showing people things in telescopes visually, M13 looks great, And for a Galaxy M51 looks great because it's galaxies are really hard for most people to see it visually because they're so faint. But M51 normally stands out, and people can imagine the spirals of it. So these other galaxies we've been showing tonight, unless you have a camera, they're kind of, oh, really? That's a galaxy? So that's where the video astronomy works really well. You can point these things, and then they can walk over to the 17-inch scope and look at the same thing and say, "Yeah, I saw it, but I like the picture better." So, but then some things on the 17-inch are just awesome, like M13 on the 17-inch is just beautiful. So this is in Hercules. You want to try to track the space station? What are you going to buy? Okay. One of these nights we'll do that.
We had a pretty good Sunday night.
I've done that on a 17-inch for people by manually tracking it, looking through the telerad and letting them watch through a 31mm eyepiece. You can actually see the panels and stuff.
Does it track it, or is it just a few seconds?
Well, we can install tracking software. These mounts will do it. I just haven't. And but in the case that I did that wasn't here. It was with another 17-inch. I was just manhandling it and just oh yeah, there it is. Whoops, no, yeah, there it is. Yep, whoop, whoop. So. But M13 is nice. You can, especially in the eyepiece, you can see some of the golden and blue colors of the stars. M13 is a 5.8 magnitude. Let's let this settle in before I read the information about it. It's well, the Beehive is an open cluster, and it's really hard to show on the telescopes. It's better in binoculars because it's so spread out. Look, is Beehive still up right now? We could go over there and take a look. But I'm pretty sure. Why'd you move it that way? Okay. All right. We'll let this settle down. Unless the thing is not tracking. There we go. Okay. Look at that. Isn't that pretty? Very pretty. Okay. M13 is a 5.8 magnitude globular cluster in the constellation Hercules, the Great Hercules Cluster. Considered one of the finest globular in the northern hemisphere, this object has a diameter of 120 light years and a population of approximately 500,000 stars. It was discovered by Edmund Halley in 1714 and logged by Charles Messier 50 years later. Viewed through a 17-inch at low magnification, M13 seems to assume a three-dimensional quality. I even say go for high magnification on it. It normally, on a good dark night like tonight, you can get that pretty large, and it's pretty impressive. So M92 is next. Oh, nice. Typo. Yeah, click on it. Let's see where it takes us.
Not far.
Okay. Lock. It says it's on the M92. Okay, typo on my touch panel.
Well, we're going to find out. See how.
Where did that come from? Okay. So is M97 or M92? M92.
We're still settling.
And this is another globular in Hercules. So
There.
that's it?
Yes.
Okay, a little bit smaller, a little bit more sparse. It's a 6.4 magnitude globular cluster in Hercules. While it's upstaged by the nearby M13, this object is quite impressive visually through a 17-inch telescope and via the Malacam on the 14-inch, which is what we're looking at right here on the webcast. With a diameter of 109 light years, It possesses about 330,000 stars. Originally discovered in 1777 by Johann Bode, it was independently found to be cataloged as a nebulous object by Charles Messier in 1781. In 1783, William Herschel resolved the object into stars. So both Bode and Messier just saw it as a fuzzy object. We are so much more fortunate than some of these people that made these wonderful discoveries that our telescopes resolved much more than they ever had. And that's M92. So next on our list is M57. Another one of my favorites because you can actually see this in a small scope. This even shows up pretty good in our 6-inch Dob, I think.
Oh yeah, here she comes.
57.
Got a composite right now.
This is a. And here we go. It's coming. One more sample. Yeah, a little bit blurry. For some reason it's blown out on the upper right. I don't recall seeing that. Let's go back in the white balance and put that one more notch of red in there. I want to see this a little bit better. Nice image of the central white dwarf, though. Yeah, go back up to the middle. One more. I just want to see it there. Okay, yeah, take that out. And then go down to zoom. Let's turn zoom on and just see. I know it's going to make it a little bit blurrier, but click that to on. You can't. Right? Use the right arrow. Center button. There you go. Okay, go down and save that off. I think that's what we're going to get. Okay. So the reason I wanted to do that was to see a little bit of the color. It's kind of a rainbowish color. You can see there's a bluish greens in the middle. Actually, go back to white balance. Let's bring the blue up just a little bit too. Play around with the colors here just a little bit. That's far enough. I take it down on one. Yeah, okay. Let's get out of there. So the Ring Nebula, M57, is an 8.8 magnitude planetary nebula in the constellation Lyra. Commonly known as the Ring Nebula, M57 is an outstanding example of the final death of stars similar to our Sun. While early observers thought that they were seeing only the thicker edge of a spherical cloud of expanding gas, recent computer simulations suggest that what appears as a ring is actually a tubular sheath of gas, with the material being ejected from both ends. More studies of this fascinating object will no doubt come up with other shape variations. The source of this planetary is a very hot planet-sized 15th magnitude star on its way to becoming a white dwarf. Look at the star visually through like the 17-inch scope using a 12mm or 17mm eyepiece. Can you see it visually? We can see it here, the little knot in the middle there. You gonna turn the zoom back off? Okay. Yeah, just go back to off mode. There you go. Take that back out. There you go. It's almost easier to see the white dot in the middle with the zoom off, huh? It doesn't blur it out so much. Okay. That's it for some of the deep space stuff. We've got a couple other ones that I don't know how well will look on the Mellencamp, but let's go to Corioli. This would be probably better in the refractor. Let's take a look and see what we get. Not a crazy double star over it. There we go. Okay. One more sample. Let's let this. We'll probably have to turn this down. Just go ahead and rotate the knob all the way counterclockwise. There you go. 2 stars there. Let's go ahead and go into VBS mode. Are you going to center it up? Okay. Jason, are you doing the imaging over there? What did you say?
Not really.
Not really? Just say, plug me in and I'll put you on. If I had time earlier, I was going to set up.
One cheek dose into another cheek dose.
I was going to set up the other camera on that 17-inch and try to do some planetary stuff. We might actually stop this broadcast, set that up, and pull up another one if you guys want. Let's go ahead and go into the menus now. Let's get this a little bit less exposed. So we're in VBS. Change that sense up to like 32. Yeah, leave it off, actually. Just leave it off. Yep. And save that out. Yep. So there's your double star. We're resolving it, and it looks a little bit yellow and blue. Let's see what it says. This is the brightest star in the constellation Canis Benedictisi. It is also an attractive double star for small scopes. With stellar magnitudes of 2.9 and 5.6, look for a blue-white primary and a dimmer yellow-white secondary. I would have guessed that it was the bigger one was blue, but on video, it's hard to say. Double stars and colors are better seen visually. Refractors are great for those. 17-inch would look pretty good on that. You can crank up the magnitude if you want. Let's go for what is it, lambda? Why Canum Venatorium? Carbon star. Let's
Scope movie?
Let's see here. That's it there?
That's it there.
Get it centered up a little bit more. Then we're going to play around with exposure, see if we can get some. We might have to overexpose it, but I want to see it turn red. I know the garnet star we can get nice and red. Yeah, but this is Canon Benedictorium, which is another carbon star. So I'm hoping that it'll be nice and red too at some point. Yeah, go ahead and put that back up to 28. I'm just waiting to see if it gets brighter here. Yeah, go ahead and go back to. I can see a little bit of reddish. Go back. Let's go to integrate mode. INT. Just playing around with it. I mean, this is going to overexpose it, but I just want to see what we're going to get. Yeah, you can tell it's definitely redder than the stars around it. So this is a J-class variable carbon star in the constellation Canis Benedictisi that displays an unusual abundance of carbon-13 isotope. The red color is caused by large amounts of carbon molecules such as carbon monoxide and cyanogen in the stars' outer layers. Absorption of the shorter wavelengths of light by these molecules results in this intense reddish hue. Again, if you look at this through an eyepiece, you'll notice that it's definitely redder than all the stars around it. So that's our normal observing list. The other things that we also look at quite often this month would be some of the planets. We have Saturn out right now. Yep. I'm going to go ahead and move to it. Scope moving. Jupiter's down. Huh? Okay. So what are you thinking? You go back to VBS mode? There it is. Center that up. So Saturn leaves a lot to be desired on a standard depth video camera. We can see some of its moons there. Definitely right around it.
Titan.
Let's see, what have we got here? Maybe I can hit center on that. There we go. Let's see. So near Saturn, what have we got on those moons here? Titan is the one that's way out to the left.
You see what, about 5 moons? You see 3 really tight, and one out about 3 diameters, and one out about 10 diameters.
What's I'm trying to make sense of my chart here. Okay, that's Titan on the left. That's really bright with Hyperion just below it. And a bunch of text over the top of it. Okay. If you're going to look at the moons, go ahead and take that back up to 128. And let's go ahead and go to integrate. Let's just punch these things up. So we're not going to make any detail of the rings this way, but we'll be able to see some moons. And it's going to do this. Yeah. Okay. Sometimes it has troubles going between the modes, and we have to let it settle down. But the other thing is that, yeah. Yeah, go ahead and go. Yeah, that does that sometimes. Okay, well, there's a lot there.
And it's Saturn, section.
Yes. You got the knob all the way counterclockwise?
It's max.
Right.
It's min.
Okay. Yeah, go ahead and go back to VBS mode. That's the mark. And then, okay, take the sense up all the way off. I just want to try something here. We'll see if we can get some ring detail. And then go down to ELC, go up one. Hit the ELC, and go into there.
Go into there.
Yep. And oops, no, actually I take that back. Go out of there, go back to ALC, and then go into there, and shutter. Take that up to about 1,000. There you go. 750. So there's some rings around Saturn. Come on back down to 750. And go out of there. And go into zoom. And yeah, it's a little bit blurry. So I just lost something. So anyway, that'll do it for tonight. Been a pleasure. Sorry we had some technical difficulties. Hopefully this sounded okay. But, good night, and until next time. Oops. Yeah, keep looking up. Huh? Put that out there right. Okay. Any last questions out there?
Well, we had another Spanish person, Tanya, but I didn't know where from.
Okay.
She didn't